For years, the James Webb Space Telescope was supposed to do something comforting. It was supposed to sharpen the story, confirm the timeline, and help modern cosmology place its pieces more neatly into the puzzle. Instead, it has started doing the opposite. The deeper it looks, the more the universe seems to resist the version of itself we thought we understood. Galaxies are appearing too early. Giant structures are maturing too fast. Strange objects are refusing to fit the categories we built for them. And perhaps worst of all, new clues are suggesting that the beginning of the universe may not have been the true beginning at all. This is no longer just a story about amazing new pictures. It is a story about a telescope that may be forcing science to admit something it never wanted to say out loud. The universe is not behaving the way our best models said it should. One of the most unsettling things Webb has done is make the young universe look old. Not slightly ahead of schedule, not a little unusual, but old in a way that feels structurally wrong. According to the standard picture, the first few 100 million years after the Big Bang should have been an era of rough beginnings. Small galaxies, weak early structures, and systems only just starting to gather mass and turn gas into stars. But Webb keeps finding galaxies that look far more mature than that, as if the universe had somehow skipped chapters and jumped straight into later development. And the problem is not just their brightness, it is their chemistry. Some of these early objects already show elements that should have required multiple generations of stars to manufacture. That means they do not merely exist too soon. They seem to have lived too much too soon. They carry the signatures of a deeper history than the official timeline comfortably allows. In ordinary language, they look like adults appearing in a part of the cosmic story where only children should exist. That is why this is starting to feel less like a normal scientific tension and more like a genuine crisis. When the universe's first structures already look organized, enriched, and surprisingly bright, the obvious question becomes unavoidable. Where did the extra time come from? Because everything about these observations suggests the cosmos had more of a head start than we thought. Then Webb made the situation even worse by finding objects that do not behave the way our categories say they should. Astronomy depends on classification. We separate stars from galaxies, quasars from black holes, proto-galaxies from mature systems. That is how the field stays organized. But now, Webb is revealing compact, distant objects that combine features that should not naturally belong together. They are too small in some ways, too energetic in others, and too strange to sit comfortably inside the boxes we built to explain the sky. That may sound like a technical problem, but it is much bigger than that. Categories are really compressed theories. They are ways of saying that we think we know what kinds of things the universe is allowed to produce. When Webb starts showing us objects that blur or violate those categories, it is not just introducing a new labeling problem. It is telling us that the early universe may have been far messier, more hybrid, and more structurally chaotic than we ever imagined. The neat progression from primitive to mature, from simple to complex, begins to fall apart. In other words, the issue is not that Webb found a weird object. The issue is that Webb keeps finding weird objects in exactly the era where our models most need the universe to be predictable. That is what makes this so serious. The telescope is not merely spotting exceptions. It is exposing a pattern of exceptions. And a pattern of exceptions is how a paradigm starts to break. As if early galaxies and hybrid objects were not disruptive enough, Webb is also helping reveal something even more dangerous. The universe's large-scale structure appears to have assembled too quickly. Not just individual galaxies, but galaxy groupings, massive concentrations of matter, filaments, and giant frameworks seem to show up much earlier than traditional models would like. This is where the problem stops being local and becomes architectural. The issue is no longer one rebellious object. The issue is that the cosmos itself seems to have built its skeleton too soon. That matters because the large-scale universe is supposed to take time. Gravity needs time to gather matter into filaments and clusters. Dark matter is supposed to provide the scaffolding. Yes, but even then, the biggest structures should not seem so advanced so early. Yet Webb keeps pointing toward a universe that behaved as if it was in a hurry. It did not slowly crawl toward complexity. It seems to have rushed toward it. Some massive systems appear to have no business existing when they do, not without some missing ingredient or some missing chapter. And this is where scientists start drifting toward much more uncomfortable explanations. Maybe there is more dark matter involved than expected, or maybe it behaves differently than assumed. Maybe there is some unknown early universe mechanism that accelerated structure formation dramatically. Or maybe, And this is the possibility no one wanted to take seriously too quickly. The timeline itself is incomplete because the universe may not have started from the blank slate we were taught to imagine. This is the part where the story turns from destabilizing to almost unbearable. Because if the alien universe already looked too mature and its structures assembled too quickly, then one possibility rises from the edge of speculation toward the center of the discussion. What if something came before what we call the beginning? Not before in a poetic sense, but before in a physical, cosmological sense. Maybe the Big Bang was not the absolute start of everything, but a transition, a rebound, a bounce, or the continuation of a previous cosmic phase. That idea matters because it would help explain the universe's apparent head start. If our cosmos inherited conditions, patterns, or large-scale instructions from an earlier state, then it did not begin as a blank page. It began with memory. That memory might be subtle, buried in the background structure of the cosmos, but it could be enough to explain why galaxies, clusters, and giant filaments seem to form too soon. The universe would not have needed to invent everything from scratch.